Hello everyone and welcome to week 5. In this week we're going to continue learning how to create a variety of new assets and try and push the volume setup that we've created previously to another level. And I'm going to start with this example and we're going to learn how to add color variation between the blocks. See here we have color shifting, so we need to add information in the volume data to allow us to do this. And this is something really complex, but hopefully it's going to be super easy to create with the help of VDB. And then we're going to learn how to create a variety of other examples. We're going to learn how to do volume subtraction, create something like this. And then we're going to create this element here. I don't remember all the techniques, but I want to show the method that I used because it's very important to understand the underlying geometry that I used before the processing, because that plays a critical part in creating the look. And then we're going to create a new type of modifier that will allow us to create something much more complex with a lot of depth to it. And the input geometry for this was very simple box geometry, no details, and we're going to modify the volume processing so that it allows us to get something like this. And then we'll be able to also add extra information to vary the color based on the noise patterns and store this in the shader so we can use it to vary the shaders per block or per element if we wanted that. And then we're going to learn how to create this. The input geometry is also very interesting, and we're going to learn how to we're going to see how I did this, and then hopefully explore some new ideas in there as well. I do think there is color variation on this one, but the setup I'm going to explain can be applied to everything we're going to be doing. We're also going to look at how we can take that complex wall and try to generate something more with less noise so we can see the actual structure. And we're going to create these two, hopefully, if we still have time. There's a lot of other cool things that we're going to be learning this week, and hopefully you guys will learn some new techniques that will allow you to create much more complex assets. So let's get started. I wanted to go back over this example and create it from scratch because I felt that the last explanation that I did, I rushed it through the example. I want to show you guys all the steps, and then hopefully we'll do the color variation, and that's something that we can add to all our setups as well. So let's get started. I'm going to create a new asset, AC workshop, and I'm going to call this brick wall live. Okay, cool. And let's start Houdini. Cool. So I'm going to dive inside this and delete the grid. We don't need that. And show the grid. And I'm going to start with a line. So I'm going to create a line that faces upward, and it has 10 units and 10 points. And the idea is I want to create stripes that we then going to fracture each one individually and extrude. So let's add a little bit of variation to those points. I'm going to put down a point FOP. And we're going to change only the height. So I'm going to create a noise and connect that to the position. And let's add that to the current position. Let's make sure it's a 3D noise. And we don't want to change everything. We just want to change the Y position. So I'm going to split the original vector, the original position, this one, and combine them again. So I need the Y from here and the X and Z from the original one. Cool, so let's export this and let's play with this value. Cool, something like that. And then we're going to extrude this but I don't remember why. I think I do remember why. I don't remember why I did this, so let's not add it at the moment. Let's just extrude these points. So I want to extrude them, tick on the global transform, and let's move the wall this way. So now we have the stripes extruded. I'm going to put down a facet SOP and make each one unique. Let's create a connectivity node to generate one random number per primitive, and let's visualize that. So color, random from attribute, class. And now we have these stripes. Cool, so the idea is I want to loop over each one, extrude it, and then generate a Voronoi. Actually, let's do it. Let's isolate one of them. And let's move this node somewhere. And the idea is I want to extrude that. And let's make sure we turn on output back. We're going to create a volume from this. So VDB from polygon. And it's a fog volume. Scatter some points. Let's just put 10 points. And Voronoi fracture. And let's tick on colorize, visualize colors, and we need to turn this off. Okay, cool. So now we have our geometry ready. Now what we need to do is we need to loop over and do this every time. So we need to repeat the same operation for each block. So let's put down a for each node and connect that. And the loop we needed to run based on the primitive, based on the connectivity. So I'm going to change this to, let me check something super quick. Yeah, I'm going to change this to a primitive, and then we're going to use that to loop over each primitive. So here, let's change it to, it's set to primitive, so let's change this to class, and let's disconnect this and connect it here. Cool, so now we should see the same operation happening, and let's disable the blast. Cool, so it's working, but the problem is the color is, the point distribution is the same for all of them, so we need to vary that. Now how can we do that? Well, the for each loop has a iteration number that we can use. So if we select this guy here and click on create meta import data, this guy has three attributes. It has the iteration number, which increments. It has the max number of iteration, and I don't remember what this value is, but we're going to use the iteration. And these guys are detail attributes, so what we need to use is the detail expression. So I'm going to type in detail, and then the path to the node, which is for each begin one meta, and then the name of the attribute, which is iteration. And let me check something. There's one thing missing. So this expression, it needs the index. So here it needs a float, and the float is 0 in this case. So this one will return the seed. Okay, now why is it overlapping? Oh, I see. So the extrude here is, oh, it has an inset. Sorry, I need to set this to 0. Okay. So we're changing the seed of the points for each iteration, and now we're getting this. Cool. So what I'd like to do now is loop over each one of these primitives and remove a piece of it, remove a portion of it. It could be this, could be this, could be anything, could be this. So we're going to create loop over each unique primitive, each unique piece, and then add a way to clip it using the new Boolean in Houdini 16. So let's do that. The first thing that we're missing right now is that if we look at the name attribute here, if we look at the name attribute, it's all set to piece 0, 1 till 10 basically. Each one of these guys have the same name, and we don't want that. We want the name to be unique for each piece, and right now it's not. So we need to make this attribute naming dynamic. We needed to also be aware of the detail attribute, the iteration attribute. So I'm going to copy this, and I'm going to type in rock for the starting element, and then backtick, and then the expression, and then backtick again. And this will embed, will resolve this path, and then it will string combine it. It will concatenate everything. Okay, so it will be rock 8 and then a number, and I'm gonna add an underscore in case because the Voronoi will add automatic numbering as well. So now when we look at the final result, we should see rock, this is iteration number 8, and then 1, 2, 3, 4 up until 9, or how much points we have. So we can see it's rock 0 here, the first one, and then 0, 1, 2, 3. And now each piece has a unique identifier. And this is great because we can use that information to do another for each loop. So let's do that. Let's do another for each, not submit work, for each loop. And let me verify something. Yeah, cool. So I'm going to do a for each loop, and this time it's going to use the primitive attribute name. And that's why we made it unique, so that we can do this. And if we look here, it's going to show us one iteration. So let's just do the clipping for this guy. And what I would like to do is, I'm not going to change. Well, let's do that. I'm going to change the scale of these pieces a little bit. So the scale I'm interested in is I want to create some more depth. I want to push the pieces in and out a bit more. So what I'm going to do is I'm going to use an expression and use the iteration number. So let's create this. Let's create the metadata node, and then here I'm going to refer that. So actually we can copy the same one. So this guy. Let's copy this, and then it's metadata to begin to meta 1. Cool. So now it should be returning the number of pieces, and we should see, yeah, that's how much it's scaling. I don't want that much. I want to fit this between a reasonable range. So what I'm going to do is I'm going to fit this between 0 and 1 using the fit expression. The fit expression expects 2 inputs, so let me hit Alt-E. The first is the start and end, which we're going to set to 0 and 1, which is wrong, but let's set that. And then the scale, we want it to be between 0.6 and 1.2, the new range. So let's hit apply. And you can see it's not doing anything because the range is wrong. And actually I'm not interested in using this incrementing number. I don't care about this. I want to generate a random number which goes from 0 to 1. So I'm going to add a rand here. And this will return a random value based on this that goes from 0 to 1. So this range here is correct. And then I want to remap that between 0.6 and 1.2. So if I click OK, you can see now we're getting interesting push and pull for the pieces. Now let's add the clipping that we want. Well, how are we going to do that? Well, the idea is we want to create a plane somewhere for each piece, placed relative to this piece, and then pointing in the direction that is interesting. So what I'm going to do is I need a point to copy this plane to. So I'm going to create an assemble node, and then we're going to pack this and let's set the view to centroid, and that gives us the point that we need. Now if we create a grid, let's see where the grid are. Okay, cool. Let's create the grid and then copy to point, and that's the point, and this is the grid, and this is the point, and now we have the grid copied. Okay, now I don't want to align it this way. I don't want it to be aligned to a this direction, so I'm going to create a random attribute and call it n, and the n, the normal, will be used to align this grid. So I'm going to create a normal attribute, and we're going to change it to be direction or orientation. And this is very cool because you can create actual normals with a actual vectors with direction with a cone angle. So I'm going to set the orientation to 1. Cool. And let's see how this works. Okay, so let's take a look at the original piece. Cool. So this is working, and we can change the we can change the angle, how wide this can open. And for now I'm going to set it to 15. And let's create a Boolean node. We're going to connect the first one and the second one, and now we want to clip the result with this. Actually we need should be this. So let's set this to subtract. See what we get. Okay, it's subtracting everything in front of it, so let's change that, and let's change this to flat shaded. Cool. Let me check one more thing. Cool, and it's creating also the filling for the piece, so everything is combined together. And let's go with this. Let's try. So let me create a color node. I want to override everything and see it shaded nicely. Cool, I think this is working. Yeah. And I want to do one last thing here. Yeah, I think this side will be fine. I want to move the points a little bit. I think they're too close to the center. The clipping is removing too much from the piece itself. So I'm going to add a transform and just move the point to the front a little bit. Something like that. So it doesn't remove a big chunk. Yeah, something like that. And now the last thing I want to add is I want to randomize the orientation of this, because right now it's the same value every time. And so what I'm going to do is I'm going to this should have a seed number. Yeah, so this guy, there is a seed number here, and we can use that to change the randomization of this attribute per point. So I'm going to copy that same expression, and we just need this, which returns the current number of iteration. I'm going to paste that, and that should randomize the result for us. Cool, so let's take a look at the final result, and now we have everything we need. I have very interesting push and pull. Cool, so the next thing is we're going to go into volume mode. But before I do that, I'm going to subdivide the geometry to add more details. And let's set the override crease weight to 1. Yeah, that's good. Set this to 2, 3. I'm just trying to get more details here. Let's set this to 6. Okay, cool. So now we have a lot more details in this, and I don't want to use this geometry as it is. I think it's too uniform, so I'd like to modify it a little bit. I'm going to create a point VOP, and in this point VOP I'm going to add a little bit of noise. So I'm going to create a noise. Okay, and let's add this noise to P. Cool. So now we're disturbing that. But what I don't like now is the fact that we're disturbing everything. And I don't like to touch these faces. So what I'm going to do is I'm going to take the normals and compute a dot product of the normals and a z vector, or what we call an up vector. So see, now we're doing a dot product. Let me turn this off. We're computing a dot product with positive y. I don't want that. I want the z-axis. So let's change that. And you can see now everything that is facing this way has a white mask, and everything that is facing anything that is not the positive z is getting black. So I'm going to clamp this, and I'm going to fit the range. I want to invert this data, so it's positive where I want to change the values. Okay, let's take a look. Cool. So now we have a mask basically for everything except the side faces. I don't care about this as well because I'm not going to use that. So what we need to do is we need to mix the modified position with the original position using this mask. So it only applies the modified points to where we have white values. So let's add this. And now it's doing the inverse, so let's connect this guy. Cool, I don't need the fit. And you can see now we're modifying everything except the front faces. Now I'm going to add one more subdivision to add more details, and you can see already it's working. And let's reduce this noise a bit. So I'm going to expose these guys, promote them. And let's increase the noise. Let's reduce it. Something like that. And let's add another one globally so everything gets affected, because I think it's too much not to have. It's too much to just have the edges. So let's add that. What's happening? Interesting. It's a 3D noise. I don't know why this is happening. Could be a display. Yeah, it's a display issue. So let's add this. Less frequency. Okay, cool. Something like that. So this is my starting point. And I'm not sure actually which side I'm going to be using, but I think both are fine. We can always flip the z-axis if we wanted to use the other side. Set this to -1. Actually, let's expose this guy, and we can always change it to select the other side if we wanted to. We can also make it work with both ignored, but it's fine. I like both. It doesn't really matter. And now we're going to go into volume land. So let's continue and start creating the volume for this wall. I'm going to create a VDB from polygon, sorry. And I'm going to set this to 0.6. Before, have more details. Cool. And let's create a VDB analysis to compute the gradient. So we do the proper displacement. And the gradient we're going to compute is for the surface field. I'm going to give it a different name, so grad. And let's create a volume VOP. Connect this, and let's create a couple of nodes. So the first one we need is a volume sample. And let's set this to read the first input. The primitive name is surface, and the position we're going to create that. The next one is volume sample vector. We're going to sample the second input. The primitive name is grad, and the sample position is this. Cool. Let's create a unified noise, and let's create the noise. And now let's modify P before it goes into the noise itself, before it goes into the unified noise, to add more breakups, and let's connect that. Cool. And then what we need to add a multiplier, we need to negate, and we need to normalize. And I'll explain what the negate is for. So this vector here returns the inverted direction of what we need to push along, and we need to negate that vector, which basically flips the inversion, the direction, instead of having to multiply the noise. And then I'm going to normalize that vector, take that result and multiply it by the noise, and then use that to sample the surface field, and we need to export that to a surface field. Okay, cool. And now we should see some changes. Okay, cool. And let's do a few things. Let's promote these guys. Okay. And I'm going to change the UI of this a little bit, so I'm going to click Edit Parameter Interface. And what did we expose? We exposed these guys. I just want to add a separator so I know which one belongs to the position and which one belongs to the unified noise. And I'm going to change this to F2 minus F1. And let's expose the frequency, so that would be frec. And let's change this to terrain. Let's enable these two guys like we did last week. And let's set this to 0.01. I'm just matching previous values here. Accumulate, fold, and then the final amplitude, which would be CC amp. And to find out which one, you can just hop over one of the parameters, and you can see it says CC underscore amp X, amp Y, and so on and so forth. Okay, cool. So now we have that. Let's go up, and this is the Worley frequency and amplitude. So I'm going to copy this as I want these values to be the same as the first one. So I'm going to paste relative there, copy this guy, and paste relative. And now let's cook this and see what we have. Cool. Now the VDB from Polygon, let's go back to this. It doesn't have a lot of room, so I'm going to add 15 voxels on each side for the interior and exterior. And let's take a look at what we have. It's obviously taking a few seconds because we have a lot of data as well. So yeah, 460 is definitely high. So let's reduce that a bit to 5. And let's lower the amplitude of the Worley. And let's lower the amplitude of this as well. I'm going to link these two so we can tweak that. Let's copy, paste relative. Sorry. Copy this guy. Paste relative here. And paste relative here. Okay, cool. So let me set this to 0. And now, interesting. Yeah, let me verify something. So volume sample from vector, we're multiplying that and using that in the position. Oh, sorry. One very important step. We need to add all of that, all of this to the position. Otherwise it won't work. Actually, it's good that it's giving us that result. It's definitely wrong. So this is going to work now. Yeah, sorry about that. Cool. Okay. So let's set this to... And let's actually turn off the noise. I want to use the position without any disturbance. And let me convert this to show you guys what we get. Cool. So this is just using the SDF and deforming that wall with the gradient. So let's actually increase the resolution. I want to show you guys how much details we can get with just one modifier like this. Cool. Okay, so let's tweak this. Let's reduce it back to 5. And let's tweak this. So the frequency, I want it to be much lower, 0.4. And the amplitude of this, I want to set it back to 1. And the final amplitude here, 0.2. Let's see what that gives us. Okay, not so high. Let's try a bit more. Okay, something like that. Yeah, I like the size as well. This is very close to what I had before. And let's increase this. Let's see what happens. Okay, cool. It's definitely working. And let's increase the resolution again and see what we get. Let's take a look. Very cool. We're getting there. And these cracks and lines are coming from the original geometry. This is very interesting as well, the backside. Okay, cool. Let's continue. And what I want to do now is I want to repeat this. I want to repeat this again, but not with this result. I want to recompute the SDF again. See here we have a little bit of clipping. We can fix that easily by adding more room. So let me reset this to 0.5 so it's faster to work with. And let's increase this to 2020. I'm always careful with this because the bigger the expansion, the slower it's going to be. Okay, cool. So let's leave it at that, and let's expose one more thing which I need, which is the offset. Let's find where that is. This guy. So I want to offset the noise because I'm gonna copy this modifier and redo the same thing again. So I'm gonna copy this. And this time I want to recompute the SDF. I want to compute the gradient, because I want to push these details based on the new gradient. I want to keep that. I don't want to use these normals. I want to recompute the normals again. So this guy. And now we're doing the same thing again for this. You can see it's pushing along this new gradient, which is very, very interesting. So what I want to do with this is add another level of frequency. So I'm going to add another level of detail. So I'm going to set this to 2 and lower the amplitude of this. I don't want it to change it too much, but I want to add finer rocks to this. Yeah, something like that. See, it's already working. Okay, cool. And then for the frequency of this, I want to increase it. Let's give it more noise to break it up even further. I want to break those finer rocks. And unfortunately now we have to go to the high res version, otherwise we won't be able to see these details because we're working on a superfine details, sorry. And so we need a lot of resolution. We can always go back to the original geometry and isolate a portion and work on that and see how that works to make it faster and basically iterate based on that. And I think the noise is too much. Yeah, the noise is too much, so I'm going to lower that. And remember, we're converting it to a surface to see these details. Okay, cool. Yeah, I think that works. It's probably too aggressive, but I'm going to leave it at that. I like this. Okay, so I'm going to we can keep doing this, but we can keep adding modifiers, but I'm gonna copy something previously created. Sorry, I'm gonna cancel and delete that, and I have I have this node here, and it's basically a noise with a volume sample. I delete this, I'm just going to add this to add more breakups to this even further. Now waiting. And I added the -f here to offset, change the noise per frame, because I rendered over 100 versions of this, and I animated all these offset noise to basically change every frame. So this is the final result. In the next video, I'm going to increase the resolution and wait for it, and then we're going to continue and add more details and add the color variation to this, so we can restore some information back and use that to shade and to use that to vary the shading at render time. And I'm going to, let's see how much we have now. Let's try 0.01, and based on this, let's wait for it. Okay, cool. Yeah, it's going to take a couple minutes, so I'm gonna hit the convert button, wait for it, and then I'll come back. So now I've waited for this. It took, I think, 2 minutes, and I lowered the resolution a bit, so it's 0.02, so it's this much, and I expanded these guys a little bit more because I saw some clipping and it's still there. I need to expand it a little bit so it doesn't run into this issue. But this is the final mesh. You can see there's tons of details here, and probably there is too much noise. I think there's a lot of small details that I think we can reduce or tweak a bit. But I really like what I have. I think it has a lot of depth, and having these kind of details is very important to create the complexity of the rocks and things like that, and these guys as well. So let me turn back the specular. And this is the geometry. Now what I'd like to do is add a way for us to control the shading per block and be able to transfer that with the volume. So let's see. So let's go back here. And the first thing that we need is we need a way to identify each one of these guys, because the idea that I want to do is I want to create a unique integer, a unique value per rock that I then transfer throughout all these steps. And when I convert into a mesh, I can have the mesh, the final deformed mesh, sample from the volume the value that it needs to care about. So we need to create that value, and this is very simple. So I'm going to create a connectivity node and set it to primitive, and let's visualize that. And the reason I don't want to store the color, because it's much easier, it's much more lighter to store a integer or a float in a volume rather than a color field. So let's visualize that attribute. It's called class. And let's see. Yeah, so it's working. This is our class attribute, and this is what I like to use. So I'm gonna continue with this. So let's subdivide that and make sure we get our information. And let's connect this guy instead. Cool. So everything is subdivided. Cool. And I'm going to change this to 0.06 so it's faster to work with. Cool. So this is our field, and if we middle click, we only have surface. And what we need to do is we need to create a new volume field that samples the class attribute. So this area here is where we can do that. So this surface attribute, I'm going to click the plus button, and it tells me what attribute do you want to sample, and I'm interested in the primitive class. Okay, and then I'm going to type in class, and it should have, it has created the attribute, and this is how the data looks like. Now it's displaying it in the viewport, and we don't want that. We want to hide it. We don't care about that data. So I'm going to create a visibility node, and with this node we can tell it to hide a specific field, a specific primitive, I'm going to select the class, and that's the name of the field. It's class. Okay, I don't care. This guy doesn't need to care about the class attribute, but yeah, it's fine. So let's continue. Okay, so now what we're doing here is we're taking the surface field and modifying it, and we're not changing anything else except that. So the original class field has not changed. It's not matching this, and we need to change that. So the way we can do that is using another volume sample. So I'm gonna turn off the compute here, and I'm going to copy this, and we need to sample the class field this time and export that as and export it again. We need to do this operation with every volume processing we do. Everything we do to the surface field, we need to do the same thing to all other fields in the volume. So class here, and then this guy as well, and same thing. And we need to sample the class. So we have to be very careful with this. If we miss one step, and then we're not deforming both fields, and we're not gonna get the result that we want. Okay, so let's take a look. It's doing its thing. Cool. And now if we convert this, we have our geometry, but there is nothing in here. There's only the points with no attributes on them. And this is normal because it only converts the surface field or the density field, and there's no way for Houdini to sample the other fields, and we're going to do that ourselves. So I'm going to create a point VOP, and I'm going to connect the first input to be the points, and the second input is our volume. And the idea is we want to take each of these points and do a volume lookup. So I want to tell it to look up at that field. And let's dive in here. We can do a volume sample here as well. So I'm going to connect the P, and the input is going to be the second input. The primitive name is class. We're interested in class. And I'm going to bind export that as a class attribute. Okay. And now we have a class attribute. Let's see if we have the correct data. If everything worked, we should be able to see it here. Awesome. And it did. Look at that. We have our volume. Now, obviously, you're going to get some variation between these guys. And the reason for that is because it's one integer in each voxels, in specific voxels, and then in the neighboring voxels it's going to change to 2. So the interpolation between 1 and 2 is going to happen in certain voxels, and that's where Houdini is going to try and interpolate that value, because in one side it has 1 and another side it has 2 or 5. So it's going to try and do its best to interpolate that value, and that may result in 3 and 2.5. It's another number, and that number run through the noise will basically run through the random thing here that generates color based on an attribute. It's going to give us a random color. Now this has not been an issue at all, and I think once we increase the details a little bit, and especially with all the textures and all the stuff that we're going to be doing, it's not going to be noticeable at all. So I'm going to increase this to 0.03 and wait for it. And then the other thing is, once we start adding more fields in the volume, the memory is going to go up. Now luckily we only have a class attribute, which is a second field, so it's not too heavy. But if we have more attributes that we need to sample, then it's going to cost more and it's going to use more memory. And let's see. Oh, it's done. So this is the result. Let me turn off specular. And this is our result. We have color variation per block, which is awesome, because we can do a lot of cool things by this, and we can vary the shading with this. And remember, it's an integer. It's a float value, so we can generate anything based on this. It's not linked to these colors. now we're going to start looking at how to create this wall here, and the primary element, it starts from here up all the way to somewhere here, and right now this version is being bent to form a 1/4 of a circle, and the original version is going to be flat. So this is the element that we're going to be creating, and it uses very similar techniques to everything we've done, but I want to show you guys all the steps needed. So I'm going to create asset, and I'm going to call this equal and demo. And I need the name of the workflow, the project. Okay, cool. And let's get started. Now I have a base geometry that I'm gonna be using, and I'll explain why in a second. Come on. I'm trying to copy some geo here. Let's see. Okay, cool. So one of the hardest thing to add when it comes to creating these kind of rocks or these kind of interleaving material that has separation but yet combined is to the hardest part is to create the cracks between the parts and make that clear and separated. And the main solution that I adopted for this is to actually create that details in the geometry beforehand. So here, for example, you can see this line here, you can see this line. All these guys are coming from the actual original geometry, and it is very important to have a very good base for that. And this case, in this example, I wanted to also have a very clear separation. I wanted this line to be clear, and this approach can also create a variety of other things, but I wanted this layering, this stacking effect as we go higher up. So, and to achieve this 2 units thing, I definitely need to use 2 separate boxes here. Otherwise, the pieces will be merged together easily. And so this is my starting geometry. It's a box. I scaled it 1 time and moved it up, and created a group A, a group B for this in case I needed to separate that, and then the original box which is this, and combine both of them. So that's my starting geometry, and then I'm going to Voronoi each one independently. So I'm going to create a VDB from polygon and just focus on one. So let's take this guy. So VDB from polygon, and 0.1 is good. Let's set this density, and let's scatter some points. I'm gonna try to keep the same values that I had before and turn off relaxation, so that, and then let's see, and then I'm going to Voronoi fracture this. Cool, so let's visualize the pieces. Cool, so right now it's not creating anything interesting for us, it's just a Voronoi fracture. And what I'd like to do is I'm going to transform all of this. So I'm going to transform this 0.2, and then I'm going to create a copy reference, sorry, not rested, action, create reference copy, do the same thing for the points, and then do the inverse. And we've done this. So we squeeze it in, and then we stretch it back to get those elongated details. Okay, cool. So let's do the same thing for the other part. And actually I added one more thing which I'm not so sure about. Actually, let's leave it at that. I'm not gonna this result is going to be a little bit different than the original one, and that's totally fine. So I'm gonna copy these guys and do the same thing here. Voronoi fracture this, and that's our result. And let me check the number of points. So this one has 115 and this one has 226. Okay, cool. So let's merge them together. Okay, cool. So let's call this, let's give it a specific name. So let's call this top so they don't collide. And this is bottom. Okay, cool. And we can merge them together and do just one transformation. Cool. So the next thing I wanted to do is I want to add a little bit of edge details to everything. So I want to break these edges. And the original geometry has some details, so I'm going to just go with that. And we're going to do something similar to what we've done before. I'm going to create a point VOP. And I'm going to create a turbulent noise this time and set it to sparse convolution, and it's a 3D noise. And let's create our vector. So let's create a cross product of n with an up vector, and let's create another cross of that, and let's normalize each one, and let's add them together. And this is our vector to displace along. And yeah, let's just add another normalize just to be sure. And then I'm going to create the noise and multiply the noise by the normals that we've created. And then we're going to add this to P. Okay, cool. So let's take a look at the result. It's all over the place. Let's tweak a few things. Primarily the noise value and frequency. So let's increase the noise. And let's lower this. Perfect. And that's all I need. I need just to break this line a little bit. That's all. And I'm not it's definitely changing a little bit the overall geometry, but I'm not too worried about this because once we go into volume, these details are not going to be visible. Cool. So at the moment it doesn't look interesting at all, and I'm going to assemble this and delete some chunks, some pieces. So let's assemble this, and I don't want to create the name, just pack primitives, and I have to delete the two boxes that I'm gonna copy. The two delete nodes, they're set to delete some pieces. So the first one has a box that basically deletes all the stuff at the front, and this is the original result, and this is after deletion. And then some I deleted some part on the back as well. So it's another box, I just moved it. And this is the primary geometry that I'm interested in. Now I'm going to I'm going to isolate some more parts. So I have another delete that I'm going to copy. And I'm just pasting them from an existing setup to save time, basically. I know this works. So I'm going to isolate some parts, and I'm going to create a reference of this, and then delete channel and non-selected. So we have this and this. And then I'm going to blast some pieces. I can simply select them by hand. So I can say this guy, and this guy, and say blast. And this is just to add more breakup. So I'm going to merge that with this. So here, delete non-selected, and then we delete them here. So these are the new pieces. I'm actually going to paste the same value that I had before, assuming that the piece numbers is the same. Okay, cool. So we have that, okay. And then I'm going to add more fracturing to this. So VDB from polygon. And let's change this to fog, and let's add more details so we have something to work with. And then let's scatter some points. And this is very important because with this method we can create the big, small, and medium details that we need to add more variation to the geometry. And let's do this. Right now, the disturbance that we added is added here. So the edge breaking that we did is before we fracture, and then we're going to fracture it even further. Actually, one thing I forgot to add: the interior of these pieces doesn't have any interior edges. I can change this to have no subdivision and then divide everything together, but we can also use the interior add details, and this will add details to the interior faces of the geometry. So let's add the detail that we need. Let me check. Okay, so 0.03 is the value I had, and this is basically going to subdivide the interior, and it's also going to add a little bit of noise to that. I'm gonna leave the settings to be the default. I'm gonna add the same 0.03, and the smaller the value, the more details you're gonna get in the interior faces. Okay, cool. So let's continue, and now we have more details to work with as well. So the interior faces looks much more interesting. And this is the original. Actually, let me copy this just to show you with and without the edge details. So this is the original, and this is with the edge detail. Okay, so let's continue, and now we're adding secondary fracture. Now this guy doesn't have, it's fracturing the geometry that was already broken, so I'm not going to add more. I'm not going to disturb it again. I'm going to leave these guys as they are. Okay, and I'm going to add a little bit of geometry and add some details to the interior as well. Same thing here is 0.03, and let's see what else do I have. Okay, cool. So the next thing is taking some time. Maybe the detail is too high, but we'll give it a couple more seconds and see. Yeah, it's done. Okay, so now we have details on the interior as well. Cool. So the next thing I want to do is I want to delete some pieces as well from this to add a little bit more variation to these guys. So what I'm going to do, actually, you know what? I'm not going to do that. Let's leave it as it is. And what I'm going to do is I'm going to assemble these guys. And what I want to add is a little bit more visibility for the cracks. Right now there is a lot of pieces, but they are all stuck up together and they're all the same position originally created at. So I want to change that a little bit to add more breakups. I'm going to assemble these guys, and I'm going to create a rest attribute to store the position. Now think of these packed primitives as just points. If we view them, they're just points, okay? And we're working with points at this point. We don't have any more geometry, just the centroid. And there's a node called exploded view. I'm gonna connect that, and if we use this node, it's gonna try and figure out a good vector that it can push these pieces along to basically to show so we can see them. So now it's pushing everything away from each other, and we're getting all the details that we have. There's a lot of cool parts, but I'm going to utilize this to create something interesting. So I'm going to create a point VOP, and remember we created a rest attribute, so we have the original position. And if I dive inside this guy and create a bind and import the rest attribute, if we connect this guy, will snap the points back. And what we can do is we can mix between the new position and the original position. Okay, now we can use this bias to offset the pieces. And this is great because we can generate a noise and then use that to mix between the original and new position. So let me check. The other thing, so the new position, you can see it's moving the pieces on all axes, but I don't want to change the x-axis. I wanted to only change the z and y. So I'm going to do a vector to float and split this into 3 components and split this into 3 components and then float to vector. And I don't want to change the x-axis. I want to get the z-axis from the new guys. And now if we take this, we can see that we're moving the pieces onto let's see, sure, yeah, it's the same. I was hoping to see less movement on the, yeah, so we're zeroing out the z-axis, so we're getting, sorry, yeah, it's correct, the x, oh, come on, I'm confused now. So x, y, z, these are, yeah, we're keeping the original vector the same, the original position for the x the same, and this way we don't have, we shouldn't be getting this. Let me think. I'm not sure why it's doing this. I was expecting it to be the original position. Let's try this. I think I know why. Yeah, I was hoping that when I move this to 0 to 1, everything should stay the same, but I guess not. Yeah, this is very interesting. But I'm sure it's working correctly, it's just that I'm not getting how it's working now, and I'm getting confused. Okay, so I'm going to skip that. I don't care about that. I'm going to create the noise. Sorry about this. And let's create, it's fine, let's create this noise. And all I care about is a 1D float. And I'm going to fit that between -1 and 1. And then let's play with the noise a little bit. Okay, and let's lower the value. Let's make sure. And let's play with the max here. Yeah, so we need to, I just want a little bit of change in terms of the piece's position. I want to create a little bit more cracks and make that reveal just a tiny bit. Something like that. And let's increase the frequency. Cool. So this is basically what I'm looking for. Though yeah, I don't know, it feels like something is wrong. But let's continue. Cool. So the next thing is I'm going to merge all this with the original mesh, which is this guy. So we have all the pieces together now, and there is parts that are fractured with more details. Now we need we've gone through a lot of fracturing, and we need a way to we need an integer that is unique per each piece. And right now things are a little bit lost, and what we need to do is we need to generate a new number, a new integer, because the connectivity node is not going to give us what we want. So I'm going to create a for each loop and loop over each piece because the name attribute is still valid. And let me assemble this. Make sure I tick off create name. Yeah, let's leave it at that. And let's assemble this. Okay, cool. And let's take a look at this. And we need to unpack the data. Sorry. We need to unpack the data beforehand. Okay, cool. So now we need to get one piece and look at how it has different colors, and we need to generate one value for this. So the way I'm going to do it is first of all create the metadata node. So I'm going to create that and then use an attribute create node. And I'm going to create an attribute called ID, and basically I'm going to take the iteration number and store that. So I'm going to use the detail expression, and I'm going to refer to the for each. This guy, the attribute name is iteration, and then 0. Okay, and I'm going to set it to an integer because that's what I care about. And the class is going to be point, and I want to fuse all the points together as well, just to make sure that each block is all contained. And now if we loop, we should have our integer. Now let me delete the colors, all the colors that we have, and let's create a new one using that ID. So it looks like there is some parts that are yes, we don't need this assemble, it's already assembled. Cool. So looks like we have everything in place. Let's take a look at the color using that ID attribute. Cool. So now we have a perfect unique number per block, and this is very important because I want to add a little bit of variation to these guys. Now I do think that these edges are a little bit too sharp, but I'm gonna leave it at that. I want to see how that looks once we start doing it, once we go into volume and start manipulating it. So let's continue and start adding the volume to this. So the first thing I'm going to do is I want to transform this so that it's bigger, because right now it's very small, and I want to copy the volume VOPs from the existing scene. So I'm gonna click the move to centroid, and then I want to scale this up. And it's very important to have the same size when trying to copy the same noise, and so that the frequency matches the new geometry. And let's see, I'm going to create a VDB from Polygon, and we'll add the ID thing later to be able to vary the color per piece, but for now I'm going to use this just the SDF, and then I'm going to set this to 0.6. Maybe that's too high. No, it's not. It's still reasonably high, but we'll go with that. And then I'm going to copy an existing setup that I have. So it's very similar to what we've done in the previous video, and there is nothing different or new that we haven't done. So I'm gonna reuse the same nodes, and I'll dive inside to prove that it's the same. Okay, cool. So this is a VDB from Polygon, and I'm analyzing that. I'm using the SDF to add the same noise that we've done, and then I'm exporting this ID attribute, which we'll create in a second. So now I need to increase this a little bit to have more room. So let's add 35. That's how much I had before, so let's add the same value. And I'm going to lower this to 0.07. Oh, 0.08. Let's see how much data we get. I think it should be fine to get an idea about this. We can also always work on a portion of this, but I don't do that. You guys, if you're having issues, or you want it to work much faster, you can definitely isolate pieces and work on them. Now, the resolution that you can push here depends on how much memory you have and how much you can wait, basically. And for some of the highest example, I think it used up to 35 gigabytes, like the entire session of Houdini used up to 35 gigabytes of memory. Cool. So so this is the first modifier, and then I'm going to add a couple more, and these are exactly the same thing that we've done, and it's the same node. I just copied it. I just copy the node. Let's see, it's a simple noise. Actually, it's a 1D noise in this case. And what will happen with the 1D noise is actually, because remember when we did the example of the sphere, it started pushing everything in one direction, and when you have just a float pushing all the points together, you will start seeing details in one side but not on the other. Okay, and you don't have to do any masking or anything. Actually, let me create a quick note. Okay, so you can get more details on one side but less on the other if you use 1D float. Now this one is not adding a lot of distortion, and let's see what's the next one. Yeah, it's a copy. It's the same copy. I'm actually going to copy this. I'm going to cancel the auto update. I want to change a few values here. So this one is 0.2, and I'm trying to match previous values that I had. And then let's see what's the next one. This one is a AA flow noise. It's also 1D. I'm surprised that I only used 1D. I'm pretty sure I did that by mistake, but I think it created some interesting effects, so I left it there. And it looks like they're all 1D noise, which is surprising. So maybe we'll add another one. So for this guy, it's set to 666, and amplitude is 0.04. Now I'm gonna copy these guys, one of these guys, and set the value to 3, 3, 3, and 0.1. I'm gonna change the noise to 3D noise. And if you look, each one of them had the sampling of the other field as well, of the ID field, and we're going to create that in a second. So let's compute this. Okay, cool. So this is the result. There's definitely a lot of interesting details added. Now the resolution is still not very high, but we're gonna go with this. And I'm going to create a VDB convert and take a look at the actual mesh that we've created. Cool. So one very unique property of this is the flat areas, the flat faces of this geometry, and I think because of that, of the 3D noise that we've added, we're losing some of that. Yeah. So I think the 1D noise helped a lot because it's pushing only one area with details and leaving the other. Cool. So the last thing, and basically the main idea, the main type that I'm looking for with this is to get these kind of details where you have a sharp edge, you have a flat side, and then you have a side with a lot of details. This is also very Cliffy-like, and it has a lot of interesting characteristic. Now, the sense of scale is something that I spend a lot of time tweaking on it, and I'm showing you guys the final result. And obviously, hopefully, you guys can use this as a start for your example. But it's very important to have the proper scale, and you can see that we have the big big blocks, we have fine cracks, we have small rocks coming out, we have super fine details. There is a lot of layering with this example. And the last thing I wanted to do now is add the ID thing. So let's go back all the way to this guy. Let's create a new field, and we want to sample the point.id, and that should create a new field. I'm going to lower this to 1.2, really low, so it cooks faster. And now we're going to see that extra field. I'm going to create a visibility node and hide that. Okay, cool. And then everything is being sampled correctly. So I'm going to take a look at the final result, and I want to show you guys a new node that we can should be a little bit faster to sample points from volume, to sample attributes from volume, and that's the name of the node actually. Let's wait. Obviously, the more volume VOPs you're gonna have, the slower it's going to be. Cool. So let's create this node. It's called attribute from volume, and you connect the geometry, you connect the volume that you want, and then the attribute name is ID, and we want to sample the, where is the, interesting, yeah, the volume is ID, sorry, and that's the name of the field. And now we should have our attribute. If we create a color and random from attribute ID, we should get our data. This is pretty much the same one that we've done with the point VOP. Okay, so what I'm going to do next is I'm going to set the resolution really high on the volume, let it run, and then show you guys the final result. And I think that's pretty much it for this example. So let's continue and explore a few more things with this asset and a few ideas that will help you guys to create some more interesting and complex details. Now I've changed the resolution to something really high. I don't know the count yet. Let's see. So yeah, it's pretty high, 0.04, and then the final result has 4.5 million. And one thing that I did when I run this, like the same one we set up, this noise value was set to 0.02, and it was not getting a lot of details on the geometry. And this side here has a lot more interesting rocks. You can see this is with the unified noise idea, and it was not pushing a lot of details like this, so I changed that. And now we have a lot more rocks coming out of these volumes. Now look at this crack here. This is really hard to create. These kind of details are really hard to achieve, and I think this workflow nails that part. And look at the detail between the top and bottom. There is a clear edge. There is also an area here where we can add some interesting mosses or grass, and or add some debris and things like that to create more to add more realism to this. Now the 1D noise adds this kind of detail. See here, it's basically flat, and then it pushes us on the other side. Same thing here. It's flat, and then it pushes on the other side. Now obviously we don't have a lot of control for this, but I think when using this method creates something really interesting. And I'm going to show a few ideas that hopefully you can adopt to understand how to add more details to this. Now what I'm going to do is I'm going to save this to disk. It's definitely a heavy mesh, so I'm going to save it as it is. Oh, the other thing I changed, is the isosurface. Now let me set this back to 0. Not so much. Let's increase it. Let's set it to 0.2. It's gonna push out more details. So we're going to go in further in the volume set, in the level set. And this is we're gonna see more details coming out. Let's go even further. Okay, cool. So you see how much variation already we're getting by just changing one slider. And let's shrink it back. Let's go inside the volume now. Boom. This is the kind of details we get. And we have to tweak this now. Look, we're starting to isolate the parts even more. Now these edges here, I'm not super happy about this, but I think with the noise and everything they're broken up. I would definitely prefer to go back and add a little bit of noise there. Now let's find a good value for this where we can see just a tiny bit of from the cracks. And see this push in? That's when we did the change in terms of depth for the pieces. 0.2. Start to creep in more. Let's try 0.3. Yeah, I think 0.3 is good. Okay, cool. Now we can also add the color. We need the ID attribute for sure. And we can look at the color. It's going to be much better now. There is definitely a little bit of issues between the edges, but it's not going to be important. I think once we start shading this, it's going to look fine, especially if you use the texture very similar. I think it's going to add a little bit more randomization to the overall effect. And let's save this file and let's read it back in. And I'm going to delete some parts. I don't want to work on the entire geo, so I'm going to blast that. And delete non-selected. Okay, cool. So with the volume, there is the gradient field, there is the gradient information, which is basically a normal. And what I'm going to do is I'm going to illustrate what the gradient is, I'm going to create points here, and then we'll come back to this. I'm going to create points in this guy. Actually, I'm going to cancel. Hopefully we won't need this anymore, so I'm going to lower the value here. And I'm going to make a copy of this. I don't need this, and I need a fog field. Cool. So we have points, and let's turn this off. Let's increase the count. Okay, so that's how much points we have, and this is our VDB. This is our VDB data, and there is the surface, the gradient here, and I'm going to change that and call it grad. So that's the information we're interested in. I don't care about the ID, so I'm going to actually remove it. Add name equal ID, and then delete non-selected. The inverse. Okay, cool. So now we have the gradient. What I'm going to do is I'm going to volume sample from these points into the gradient. So I'm going to create a point VOP. Maybe I should have done this from the beginning. But I think you guys will get the idea. So sample vector, and we want to sample the second input. The name of the primitive is grad, and the position is this. And I want to connect that to n. And let's visualize this guy. And look at that. That's the gradient of the volume. And look at how the normals are pointing. They're pointing in a very interesting way, that when we use them with the displacement, we get the proper displacement on the geometry. Now anything, we can do the same thing to these points because they have the normal, the same position as this. We can try anything we want. Let me actually increase the point. How much we have? 1 million. Let's increase it a little bit more to 3 million. And I'm going to add a noise. And it's a 1D noise, and then I'm going to multiply the noise by the gradient, by the normals. Let's do the inverse. Okay, and then I'm going to add that. And let's make sure we normalize our vector. Let's connect that. And now we're moving the points along the gradient, and see, they're being pushed in the correct way. And that's what's happening with the volume. Now, why am I showing you guys this? Well, if we go back to this guy, to this geometry, okay, we can sample the gradient from here and use that to do further processing. Now, what I mean by that, let's do it on the volume so I explain it properly. I'm going to create a point vol. I'm going to dive inside and create a dot product. And I'm going to compute the dot product of n with an up vector. Okay, and let's connect that to color. And look at what we have. We have a mask with anything that is pointing upward set to white, and anything that is pointing downward is set to black. Now, how is this useful? Well, we can do this. We can take that information and remap it. Actually, the remap is not going to work here. So we can remap it this way and create very interesting masks. And if we can do it on the geometry, we can do it on the cliffs as well. And we can also run it on the simple geometry. So this is our input, and this is what the SDF will look like. It's going to match this geometry. So when we run the dot product of the normals of the volume, we can create masks like this. Now let me illustrate that. Going to wait for this to cook. Okay. And for the sake of time, I'm going to kill the this field here because I don't need it. And let's make sure we have something light to work with. Okay, let's go back. So this is our density field, and what I'm going to do is I'm going to create a dot product. Let's cancel this. I'm going to create a dot product of n, which is basically the normals of the volume, with an up vector, and then I'm going to plug that into a ramp and use all of this to multiply, use that to multiply all of this result. And let's add a multiplier because we may want to change this. Let's expose this. Okay, cool. And then we have that. Let's turn it back on. Now it's set to 0. We're not going to see any displacement. Set this to 2. And we should see details only on the parts facing upward. Okay, let's convert that into a volume. Into a mesh, sorry. Okay, cool. So you can see now we're adding only rocks at the parts that are facing the top. Now let's play with the ramp a little bit. Obviously I need to change. Yeah, let's try this. Cool. So now we're adding details only there. And this is very powerful because what we can do is we can change this. Let's say we want to affect parts that are facing only one specific wind direction. Let's say this guy, okay? And the wind is coming from this angle for the entire lifetime of this rock, which is not very realistic, but we can have details facing a specific angle. You can see now the rocks are only showing up here because that's what the dot product is giving us. And the other thing that we can do is because we have, let's see, trying to think of an easy way to explain this. Now we have that field, which I killed, so I need to put back. We have that field called ID, and this guy is it's a single value per block. So let's take a look, and let's create a random. Let's first sample the position. So if we're going to access it directly, we can just do a bind and import the ID. Yeah, we don't need to volume sample. So we have the ID. We can generate, pardon me, we can generate a random number based on that, and let's use that to multiply the result. So we're generating a random number based on each block here, and we're using that to multiply the result. Let's see why it's erroring out. It's still cooking, so let's take a look. Missing data storage. Interesting. Could be that we're not reading it. So let's do, just to be safe, let's do a volume sample, and we can verify this later. So we want to volume sample the ID data. So I want to set the name, ID, and first input. And I want to generate the random number based on that. And then we're exporting it again here. So they shouldn't collide at all. Okay, let's verify this. We have the ID. Oh, I see. One thing, we changed something, which is the grad here. So I need to keep incoming data, and I'm not gonna change this. And let's make sure we're sampling the correct gradient. So it's primitive number 0, but here the ID is. So let's do this. Let's create a custom name and change this to use the correct guy. Okay, cool. So let's take a look now. It should work, and we didn't have to do the change that I did to sample the ID. Okay, cool. Now maybe the change is not that obvious, but we're getting randomization between these blocks, and with that number, we can generate various vectors. We can generate 3 different vectors, 3 different floats using this. So we can generate a 3D normal and then plug that into the dot product. So instead of using one specific vector, we can tell it to use this vector instead. Okay, and let's normalize it to make sure that it goes from 0 to 1, and we're doing a dot product with the noise from here with the normals from the SDF, from the science systems field. And by doing that, we're getting a random vector per block, per each block, where it's going to add details. So look at this. We're getting detail on this side. We're getting details at the top. We're getting details on the back. It's random per block. And here it's more randomized. I think the SDF is pushing these details a bit more, but I'm not so sure why. It could be because of the position of this element. But you guys hopefully get the idea. Or maybe the normals are only in this side are facing more here. So I think that that's one idea on how you can use the gradient to vary, because what we've created so far, we didn't have control. Like when we wanted to add details, we didn't have control as to what side we add details to, and with that method we can say we want to add details here as well. Now, one more thing that we can do to still process this even further, we can do this. We can add a smooth operator. Maybe I should have done it with these guys. This is less details, less geometry. So I'm going to change it to curvature dominant, and I want to increase this. So I want to lose some more details. Okay, let's compare. Maybe this too much. I want to soften it. Yeah, something like that. Cool. So now we can input this, and use that dot product to blend between the two results. So I'm going to import the P from the second input. I'm going to mix between the original position and the new position using this mask. Let's take a look at what we have. And let's make sure it's, I don't like the dotted line, so it needs a float. Okay, cool. So now we're mixing the details between the smooth result and the original one using the dot product. And let's export this guy. Okay, let's export this guy and let's change the orientation. You can see how we're affecting that. Now what I would like to do is, let's see, this is based on, yeah, I want to do something where we can control this directly, but it's going to be based on this space, so it's fine. Let's do that. I'm going to subtract the 0, which is constant. Let's add a constant. 0 being the origin, and then I'm going to promote this. And let's see, I'm going to add a point. Okay, I'm going to copy this point and paste relative here. So what's gonna happen is, sorry about that. Let me make sure that this is a vector. Okay. Let me verify. So second position. And I don't need that. I'm going to delete this. And this is what we're going to use. Now I'm going to create another point, which is this guy here. Where is it? It's there. And then if I move it here, we're going to create a vector going from here to here. And that's what we're going to use to compute the dot product. And based on the alignment of this point relative to the origin, we're going to have a vector that we can use to basically to do the dot product with. And this is what the subtraction is. It's 0, and then this is the position of the vector. Basically, I'm going to normalize it. And now we have that. So let's take a look. And let's maybe move this to the origin so we can have better display of this. Let's move it to the origin. Okay, cool. And now we have our point. And if we move, we should see the result changing. It's not. Let's see why. So let's copy this guy. Let's make sure it's linked. And now it should work. Yeah. So I think it's working, but not in the right space. It's doing something, yeah. Yeah. So you can see we can use this point to compute the dot product, and that will generate a mask for us that we can use to blend in between the original position and the new position. Yeah. Look at that. So this is one idea, and hopefully you guys will be able to get inspired and try new things. You can also randomize this per block, so we have that ID information that we can always use to vary the result per block. And I think that's pretty much it for this asset. We're going to learn how to create a few more and hopefully show you guys some more cool tips and tricks. So now that we've covered a variety of examples, we're going to go back to the volume displacement that we created and try to improve upon that. And I'm going to start with this box here. And the idea is I wanted to explore new different noises to break this up. And I'm going to start with the VDB from Polygon as usual. And we're going to create the surface field. And let's add a little bit more padding to this. Okay, and let's increase the resolution. Something like that. maybe a bit more. Cool, and let's compute the gradient. So we're going to compute the gradient to that. Let's give it a custom name, grad. Let's create a volume bump. And so far, all what we've been doing is using the unified noise to do the displacement for us. The unified noise is definitely great, but it has some limitation, especially with the seed not being available to us. I think that's a big drawback. So we're going to create our own. And what I'm going to do is I'm going to create a volume sample vector to get the gradient first of all. And the name is going to be grad. Let's connect that. Let's call this gradient. And let's negate it and normalize it. Okay, cool. So let's create another volume sample. And this time we're going to sample the density, the surface. And we're going to bind export that. Okay. We should see, yeah, it's changing because we're using the gradient as the input, and that's wrong. We need to add the gradient to the position. So let me connect that. And now we should see a uniform push in all directions. Now let me lower this a bit. I'm gonna multiply it by 2. Yeah. So you can see the volume has been pushed. And let's add a multiply by constant just to show you the effect. Yeah, we're going to see it go in, and then we can also go negative as well. Cool. So what I'm going to do is I'm going to delete that, and we're going to create a worldly noise this time. So let's create a worldly noise, and let's connect it to position, and let's subtract the F2 minus F1 to get the interesting rock-like shapes. And let's take that result and multiply the gradient by this and see what we get. Boom. It's already working, and we have rocks inside our SDF. Okay, cool. So the next thing I wanted to do is I want to change a few things. I want to add a power to this node to make the displacement a little bit sharper. So I'm going to add a power node to basically add more contrast in the black and white alpha, something like that. And then I'm going to add something new, which is based on the seed here. So if we take that seed and create a random number, generate a random number, and then fit that between, it's already between 0 and 1 because that's what the random function will give us. And I want to fit this between minus 0.2 and 2 and 0.2. And then I'm going to add this to the result of the worldly noise. So let's add that. And what's basically from we know this from the previous week, from week 2 and 3. This is going to generate a uniform, a single number per cell, and we can generate a random number that is basically black and white, that goes from 0 to 1 per cell. And by taking that information and using it here, we can offset. We can push the volume out or in. So let me increase this. And we should see more push and pull. This is the kind of stuff I'm talking about. See how this block came out? Actually, let's lower the noise frequency. Yeah, so we can see it exactly. So you can see how we're pushing these volumes out, and this is because of that. Let me multiply this by a constant so I don't have to change the range. I'm gonna leave it back at 0.2 and 2.2, and let's set this to 0. Okay, now we have just the worldly effect, and if we start increasing it, we're going to see more push and pull between the cells. And this is great because we can create more depth, and see how this part is floating here. If we didn't push it too far, it's going to create something really interesting. It's going to create something like this where it I need to go high res to show you guys, but that's basically the idea. Now let me set this back to 0.6, change it to 0.6. And what I'm going to do is I want to change the input. I want to change the add noise to P. So I'm going to create a noise, 3D noise. And let's add that to the position. Okay. And let me copy the values I have before. So I'm going to change this to auto update back. And now you can see we have more breakups happening. Now let me change this to 2.6, 2.6, 2.6 to match previous values I had. And let's lower this a bit. Okay, cool. Now this is with just one noise, two noises basically. And all I'm going to do now is I'm going to increase this. Okay, let's go even higher. Cool, and let's add a bit more to the bands, to the exterior and interior, so we don't run into gaps. And I will show you how this is going to look. Okay, we still have a little bit of gaps, but I'm not going to worry. So let's convert this now. It's still not super high res, but let's convert it to volume. Sorry, let's convert it to a mesh and take a look. So this is the result. And with just one noise, with just two noise patterns, we were able to take this from a flat box to this, and see the kind of effect we're getting now. We're getting, see here how it's pushing the volume, but not just in X and Y. There is depth to it. There is layering happening. Look at this part on top of this super flat area. This is very, very interesting. This one as well. And basically this is the next modifier that we're going to be using. See this block here? And there is so many options to what we can do to make this even more interesting. I'm going to turn off the compute. I'm gonna change the resolution back to, let's say, 1.5, and let's copy this noise and let's set it to how much? So 0.6. Set this to 1 just to try an idea. And I'm gonna copy this again. And let's add these two guys together. I'm gonna use this to drive the frequency and see what I get. So just two noise patterns added together. Maybe lower this a bit. And I'm gonna use that in the frequency, and in the offset I'm going to connect the same guy here. I'm actually going to add a multiplier just in case I wanted to change how much offset we're getting. Now let's see what we get from here. Okay, cool. So I think it's a little bit too much, so let's lower this. Okay, cool. Let's lower this a bit as well. Okay, and let's lower this as well. Yeah, too much disturbance happening to the volume. Let's try and lower this guy as well. And you can see now we're getting a variety of different resolutions. The cell size is very different between each part of the box. Okay, cool. So we'll leave it at that. I'm going to multiply everything down a bit. and this controls the how much push and pull we get from the layering effect that we're doing. So the higher the higher this, the more push and pull we're gonna get. And let's try and remove this power node. I'm gonna get more rocky-like shapes, and let's multiply all of this down a bit because I think it's just too much. Okay, something like that. Let's add 0.4. Yeah, something like that. And what I'm going to do next is I'm going to increase the resolution to show you guys what kind of details we're getting now. And basically this is the next modifier. We're going to create this asset. So we're going to create this one, and basically everything you see here is done through one modifier, but the interesting part is creating the original geometry, so that's where we're going to be spending most of the time. But the modifier is pretty much this one, and see how we're getting this super flat area that has very interesting edges, and then a big block with completely different patterns, and surface smoothness varies a lot, which is a very important behavior of the rocks formation. See this part here, this is very, very interesting, and I actually really like this one. Okay, so that's the idea. The next thing I wanted to do is I want to add variation for this. Now, this guy here, there is the seed number, and I want to export that. So what I'm going to do is we need to create a new field for this. So we need to create an empty attribute. I'm going to use a wrangle node. This is basically an attribute create node, just easier. I'm going to create a temp float, and it's equal to 0. And then here I'm going to stem that. Sorry, we need to visualize it. Let's change this. Okay, so let's temp that. So we have a float field, and let's call this ID. And then here, let's copy this, sample the ID, sorry, let me think. Yeah, I think we can we don't need to do this because the result is coming from this guy. So let's try and just export this into the ID without sampling. Okay, let's hide the visibility. Let's set a visibility node and hide this. Okay, let's convert the points. Let's do attrib from volume. The attribute that we're interested in is called, we're gonna name it ID, and the source volume is also ID. Okay, cool. So hopefully we have our value. Okay, it's saying it's oh, here, yeah, the attribute size. Okay, cool. So we have the float number. I actually don't want the result of the random. I want the original seed because I want to generate something else from there. Okay, cool. So now we should have an integer. Let's see. Let's convert the int to float and see if that does it, because the signature here changed. So let's see if that works. Yeah, so we needed to convert that value to a float. Okay, and let's set this to float. Good, so let's create a color node, random from attribute, and the attribute is ID. And look, we're getting very interesting randomization now. Obviously it's giving us a black and white because the value is just a single float. So what we can do is we can create a point VOP, dive inside, and then import that ID. Okay, import the ID attribute, generate a random number, and set this to 3D color. Now we should be getting color per block. Now obviously you can see there's a lot, there's some issues here, but it shouldn't cause us any problem. Once we go high res and try to use this to vary the shaders, I don't think it will cause any problems. Now let me go to high res version and show you guys the kind of details. Now this is the main reason I made this is to be able to use the seed number to push and pull the parts, as well as use the seed to colorize these blocks. And you can see now we have successfully done that. There is a little bit of jittering here, but there is not so much that we can do about that. Going to verify one more thing about the exporting this right away, because I think, I'm gonna verify this quickly. Yeah, this is correct. So we can just export this the seed directly into the ID, and that's how we do it. Okay, cool. So let's in the next video we're gonna start creating the original geometry for this, and then copy paste this modifier and apply it to our new geometry and see what we get. So now we're going to create a new asset, and I'm going to use the script here. So create asset. I'm going to call it Sharp Cliff Demo, and I'm going to give it the name of the project, which is AC Workshop. Okay, cool. So let's open the file and let's get started. So the for the sake of time, I'm going to copy an existing graph that we've covered so much the steps for doing it, and I'm gonna go over the steps quickly. So it's basically a box that I started with, transformed it to smaller, VDB from polygon, scattered some points, transformed the points a bit further, scaled them down so we get more stretching, and then added a little bit of jittering for this, and then used the Voronoi node. I also took the interior detail to create more details on the interior parts, and then I added a transform to stretch them back. And the main thing that I'm looking for is parts with sharp ends. So for example, this guy here, okay? This part here is interesting. This part here is interesting. So I'm going to hand pick few. These guys are interesting as well. This one. So I'm going to hand pick few and then arrange them so that we get some interesting base geometry to create that cliff. But before we start doing that, I want to add a little bit of edge displacement for this. And the previous examples that we've done was a little bit of a dirty method, and I want to improve that a little bit more now to basically retain all this geometry as it is, and just disturb these guys without basically destroying the geometry. So what I'm going to do is, before we created the normals, taking everything and applying the normals to it, the tangent, we're computing the tangent of the normals on all the geometry. And this works when you have an enclosed surface, but when you have a piece like this where the interior parts should follow the exterior part. For example, when I distort this, when I move these points along this direction, the interior faces should follow this, and with the previous method they were getting pushed out. Okay, so we're going to fix that, and I'm going to isolate the two parts. So I'm going to isolate the interior by separating the groups, and I'm going to isolate the interior faces. Okay, cool. inside. Sorry. And I'm going to copy. So we have the normals here. I'm going to copy this normal into a new attribute. We can use an attribute create, but for the sake of time, it's much faster to do it through the wrangle. So we're gonna create temp n and simply equal to n. And what I want to do is I want to transfer the normal from here into this geometry. I want to transfer that temp n. So I'm going to create a transfer, attribute transfer. For this is my goal. This is my my source, and I want to transfer temp n. And that's it. Now I'm going to merge the geometry back, and I'm going to use that temp n to push the points along. Okay, to compute the two vectors that we're going to push the points along. Okay, cool. So let's create the point VOP to do that. Point VOP, and we're going to import the temp n. It's a vector, and we're going to compute the cross product of that with an up vector, and then compute the cross product of that result with this. And I'm going to normalize each one of them. So normalize this and this, and then I'm going to simply add simply create a noise. So I'm going to copy an existing one. It's a turbulent noise. It doesn't really matter which one you use. And then instead, previously we were using all the noise to multiply both vectors. In this case, I want to multiply each one with a float, with a single value here, basically a float noise instead of a 3D noise. So I'm going to split this into 3 vectors. I'm going to multiply this by the x and this guy by the y value, so we have different noise per axis. Okay, and then I'm going to add both of them, and we're going to add all of that into the existing P. So let's put down another add node. And let's plug that out. See what we get. Cool. So now see, we're getting a much better result, and we're not changing these faces. And let me change this to facet flat shaded. See, we're not destroying, we're not pushing the points out. Now there's a little bit of issues here at the top, but I'm not going to worry too much about that, as the VDB will take care of that. I'm mainly interested in this. Now see how these guys are being disturbed a lot. I don't want that, and I want to fix that issue. So the way I'm going to do it is I'm going to go back to the original geometry here and find the edges of this. Create the geometry that has just the edges. So I'm going to put down a carve node, which basically converts any geometry edge into a primitive into a polygon, or just wires. And I'm going to scatter some nodes, resample this to have more points. And let's resample it to 0.01. I'm going to give it a color, white, and then I'm going to give this guy a color, a black color. So here. And I want to transfer that information. So attribute transfer. I'm just using the color to show you guys what's going to happen. So right now everything becomes white, and we just need the color, and we need to play with the values. So let's lower this to 0.1, and let's blend the results a little bit. Okay. We verify something. Okay, cool. So that's what we're going to use as a multiplier for the noise. And let's see. I can add a divide node to help this, but I'm not going to worry too much about that. So now I'm going to import that color here. So it's in the color channel, and invert it or actually let's keep it that way. So I'm going to mix between the new P, the new position, the new deformed position, the original position, using this mask. And let's take a look at the result. See, now we're not deforming the edges anymore. And let's delete the color so we don't have any issues visualizing the result. Okay, cool. So now we have that. There is a little bit of issue here. I'm not sure where it's coming from, so let's see if we can fix it with this. Yeah. I think that's fine. So now we've broken all the edges, and this should work pretty well for us. Now the next thing I want to do is I want to the displacement that we're adding to these edges is affecting all the interior pieces as well. The interior parts, let me do an exploded view. So the displacement is affecting all these guys as well, and I don't want that. See how we're getting these issues? I want to only affect the parts that are near the edge of this piece. And there is a very handy information that we can get. If we go back to the Voronoi, there is a feature where we can control the noise along the depth, and this gives us a ramp that goes from here all the way to the interior of the geometry, basically. And to get access to that attribute, we have to go in the attribute section and make sure to keep internals. There is this guy called depth. Okay, and if we take a look at the values here, we can see it goes from 0.009 to -1 basically. So what I'm going to do is I'm going to use that also to blend in all of this. So what I'm going to do is I'm going to create a rest attribute to copy the position of the points at their original state, and then I'm going to create a new point VOP. I don't want to do everything in one place, so let's create a new point VOP, and let's bind import the rest. Okay, and then mix between the new position and the rest using that depth mask. Cool. So now we have this slider. This is the original. This is the deformed, and I want to import the depth mask and use that. So I'm gonna bind import the depth and fit the range, and the range was going from -1 to 0.09. So let's call it 0.1, and let's take a look at the colors here. Sorry, the range is this. This is 0 to 1, and boom, see how the interior is black? We can also remap this, but I'm not going to worry too much about that. So let's take a look, and now it's inverted. So let's change this, and we're not changing the interior anymore. Take a look, we're not changing the interior faces anymore. And let's actually take a look at this in the exploded view, and let's dive inside. Hit Alt D to make a copy of the panel. Let's go up, and I can change this to basically have the deformer not affect any pieces on the interior side. So this is fully deformed, and this is the interior pieces restored. Now I don't want them to be like that. I don't want them to be very uniform, and I'm going to use this to also create a new noise. So I'm going to create a turbulent noise, and this one I like to use when it comes to geometry. It creates very interesting overlapping effect. So I'm going to set this to a 3D noise and add this to the position of the points. Actually, we need the original, so I'm going to add this to the rest position and use the rest to generate that as well. And then we're going to use the invert of this. So where I don't have the the noise from the edge of displacement, I want to add this noise in. So I'm gonna change this to 0 and 1, and let's mix between this result and this result. Okay, cool. And let's use this guy to mix. And let's see what we get. I'm going to try and increase the noise to make sure that it's working. And we should see this effect only happening on the interior parts. Right now it looks like it's happening on everything. Let's try 0 and 1. And it looks like it's affecting everything. So I'm gonna copy this and invert the values, and let's see what we get. Yeah, it's still affecting everything. So let me take a look at the result, and we may have to do it separately. So this is the mask. The data looks correct to me here. Basically what I want to do is I want the new noise to be applied here only. So I'm restoring that. Let me take a look at the rest attribute. Okay, let's take a look at the rest deformed. That's too much. Let's try. Oh, we're looking at it with the, sorry. We need to be looking at it with this guy. Okay, so let's take a look at this. I think you guys got the idea. I'm trying to get some noise on the interior faces without changing everything else. So I think I'm gonna leave it at that. I will share the original file I have to verify this, but so far these are the pieces that we have, and the front face is very flat. Let me change this to flat. Interesting. So basically this is what I'm looking for, a flat face on the outer layer and then a disturbed interior faces. And this is the kind of pieces that I'm looking for to delete. So what I'm going to do is I'm going to hand pick few pieces and then rotate them and align them so that we can create something interesting. Let me delete that. The next thing I want to do is I want to create I want to loop over each one of these pieces and fuse them. So I'm going to create a for each loop, and so far I think we have a name attribute, so let's, yeah, we have a name attribute. I'm just going to fuse these guys. Okay, and then I want to add a little bit of gap between the geometry, so I'm going to create a transform, and I'm going to set the pivot to be $CX, $CY, $CZ to give us the centroid relative to this piece. And then let's change this to 0.98, just a tiny bit, to add a little bit of gaps between the pieces. Cool, as you can see. Okay, and then the next thing is I'm gonna copy and paste this part, and I'll explain it. I'm gonna recompute the normal. Don't think it's doing anything in this case, but it shouldn't matter. Once we go into volume, everything will be fine. And I'm gonna assemble this so it's packed primitives, and I'm going to, let's say, select this part, this and this, remove them. Sorry. I'm going to create a blast node and select this, and this piece, and hit enter, and then delete everything. So these are three pieces that I'm going to use. For example, I'm going to select this and transform it. And do something like that. And that's basically what I've done here. So let me show you the result. I isolated parts from here and deleted some more and some more. So this is what I left with. And then I transformed that, rotated it, and moved it to the top basically. And then did the same thing on the other side, deleted some pieces and have this at the end. And then I aligned all that together. Now it looks like the alignment that I'm using here is very different from the original naming that I have, and I'm not so sure why is this happening. I was hoping to get the same selection, and let me show you the original one. So these are the pieces that I selected, and these are some more pieces from the other side, and then I rotated them and made this basically. Okay, so this is my input geometry that we're going to use, and I think the key part for all of this is the input geometry. Now let me rotate this 180 degree to show you guys how this looks like. And if you look at it this way, it has a lot of interesting starting geometries that we can use. Now what I'm going to do is I'm gonna use this setup to quickly show what's left for us to do, and I'm gonna copy the previous stuff that we did. So I'm gonna copy this, paste it here, and this is from this file. Okay, I just copied the whole thing. I'm gonna connect that, and let's lower the resolution just to be safe. Okay, cool. So that's the geometry. Let me disable this. Okay, and let's increase the resolution a bit more. And it looks like it's complaining about something. Oh, I see. Yeah, this should be ID, not temp. I'm not going to worry about that. So let's remove that field and let's disable this. So this is our input geometry. It's not very high res at the moment. We're going to compute the gradient, and let's see what we get with this node as it is. So this is the result. Let's convert that into polygons, and let's take a look at the result. You can see we're getting there. There's a lot of push and pull being added, and let me show pretty much the same thing happening here. Let me show it with the original one I have. So this is the input geometry. Let's make sure the polygons are good. Okay, and then this is the modifier that I have. It's exactly the same one, just with different settings here. So let's take a look at this and see what we get. It's probably going to take it didn't take too long. Okay, so this is the result, and let's convert that into geometry. And this is the final geometry. Well, not the final, but the final displacement the final settings that I used. And let me show the high-res geometry. This is it. So this is the high-res geometry with just one volume VOP. There is nothing else into it. There is just that volume VOP that pushes all these interesting volume outside and creates all these nice details. And again, the combination of the original geometry to get these nice lines is very, very important. We're also defining all these cracks, and that's all coming from the original geometry. Now look at how this is blending nicely with the rest of geometry. This is really, really cool. And getting these kind of details is really hard. Now look at this line here. That's coming from the Worley displacement. The Worley F2 minus F1 thing that we're doing. And let me show you guys that flipped. I removed some parts, the floating pieces. Here with this blast, I think. And all what I've done for this one is that it's the same block, I copied and rotated it a few times. So let me show this transformed first. I mean pointing downward. And it's a very high res mesh, so it's gonna take a few seconds for this to happen. There's also this recompute affected normals, which slows the operation a bit. Now this is the piece, this is the geometry, the main one, and then I copied that a few times. And let me actually do this. I think if I assemble this, we should be fine. It's assembled, so let's try. Yeah, no, it's still slow, but that's how I created this. It's just one unique instance, copied and rotated that, and then the shading is done using a real texture in this example, I believe. And then I added also, you can see there's a little bit of variation in terms of texture between these. So I used the seed value like we did here to add a little bit more variation. So that information is very critical. See here, it's getting green, it's green here. This is different as well. So there's the variation between the blocks. And I think that's pretty much it for this example. I will include the file for this for sure, but you can see everything we're doing is simply creating an input geometry that is rather simple, adding a little bit of edge displacement, and then using the one single volume VOP to create all of this. Now we're going to take a look at how I created this asset, and for the sake of time, I'm gonna go over the setup briefly because we covered pretty much everything. I think 90% of the stuff I did here is explained already, so I'm gonna save a little bit of time and go over this setup and hopefully be able to show you some more cool stuff that you guys can get inspired from. Okay, so the input geometry for this was basically these guys. So I made 3 boxes and added a Voronoi fracture to them and deformed the front a little bit to create this, just a little bit of variation overall. I was looking to create something where I can have stairs in between. So the idea is to have these rocks and they would lead to something, someplace higher up, and these would be the sides of the stairs that could go in. And I was just trying various things here. And then I basically created an SDF, which is something we've done a lot by now. And with that SDF, I also added a field called data. And then I duplicated that field to add one, to make an extra field for me to use. So I used the blast node to isolate that field. If I middle click, you can see it's isolating data. And then I simply renamed that to data B and merged that back in. So now I have surface, data, and data B, and I'll explain why I did that. Now the volume VOP is pretty much this exactly the same one that we did previously, except I added one more layer, and I'll explain that in a second. So here you can see I'm connecting the Worley. This is exactly what we've done in the previous video, and I'm driving, varying the frequency, the offset, and adding a little bit of noise. Now I also added a Voronoi noise, which is exactly this guy, except it has this jitter attribute that can vary the cells a little bit. And I added another layer. Now the layer I added have this frequency, so it's 0.5. It doesn't have any variation on the frequency. And I also used the fit to basically push and pull the data. That's what I needed it for, and it uses exactly the same inputs as all the other things for the Worley setup. So I'm very confident that you can get the same result with just duplicating this or making a copy of the Warley, but I was trying to explore something different here, and I think that added a little bit of variation to the final result. Then I'm running a VDB analysis on that to create the gradient again, and this is exactly the node that we've created before without the extra Voronoi noise added. So it's exactly the same thing, just tweak it a little bit, the values. And let's see if I can cook the result. Let me resample the VDB field. So it's 0.02. I'm going to resample it to 0.06. That should make it lighter for us. Okay. So we have less data, and let's see this. Let's see the result from this node. Okay, cool. So you can see now we have a lot of push and pull, and I went a little bit extreme with the values. I wanted to get actual blocks out. So you can see here there's a lot more push and pull happening. And then what else did I do? And then inside this node, I'm exporting the data, which is the cell, which is the seed, and then I'm also exporting the Voronoi seed, which is plugged into data B. Okay, and then let's take a look at this guy, which is another Warley added on top, just to add a little bit more variation. Yep, and it's adding more rocks here, and then converted that into geometry. Okay, this is the geometry, and then I used a point VOP to sample the attributes, and the reason for this is because I can, with a point VOP, I can sample as much as I want, and I gathered the data and data B inside these points, and I don't remember where the data C came from. Oh yes, so this guy here, I exported data and data B, and then here I exported data and data B again, I believe. No, just data. I exported the data again. So, and then I sampled that again, but this time I exported it as a data C attribute. So I can have, I don't override these two guys, and I have a third attribute. And I think that's pretty much it. Let me show you the final geometry. No, it's not this one. It should be much higher. It definitely should be much higher, but let me show you the values. So this is the data attribute. You can see the variation in the blocks. Data B, this is, I believe, the Voronoi cells, which I'm not super happy about because we don't have any breakups, and that's super easy to add. And then data C, this is another layer, and I can use all of that to vary the shading. I believe none of it was used in this example, don't remember exactly, but obviously you can see how much information we have to create a lot of interesting things. Now, one thing we haven't done is take a look at the interior of these guys, and most of the time we'll get a clean result, most of the time, but in a lot of other scenarios as well, we're gonna get some issues with the geometry. Now let me take a look at this guy. Okay, so this is the high-res geometry. And if I go inside, you can see it's pretty clean, but there is some stuff here. There is some stuff floating here, and there is not so much that we can do about that. And this is actually much more terrible in another example that I didn't go inside, which is the straight wall. Let me see. I don't think I have the picture here. I think, yeah, we did it in week 4 maybe. No, this one. Yeah, so this one, the interior of these guys is much more complex than this, and there's a lot of floating geometry in space. and that's gonna cause us a lot of problems. So what I'm gonna show you in the next video is rather a complex setup that was shared to me by a friend of mine. His name is Alessandro Nardini. He's a great VFX artist, and he was kind enough to share this HIP file with me. So I'm going to show you how it works, and hopefully with this setup we should be able to clean any complex geometry, and hopefully you guys will be able to use that. So let's look at this mesh cleanup method that I talked about, and I have the geometry here from the previous example, and we haven't looked at the interior of this geometry at all, or at any of them. And if we go inside, we're going to find an unfortunate truth. And if you look here, there's a lot of floating pieces, there's a lot of floating details. So how are we going to solve this? Well, there is a way, and it's a little bit complicated, but I'm gonna try and illustrate how it works. So let's say we have this box here, okay, and this is the silhouette. Try. It has some details like that, maybe some details like that, some details like this. Maybe this is our geometry, okay? And then we have pieces like this. We have floating stuff, we have stuff connected, and how are we going to isolate only the exterior surfaces of what we think is the exterior surface? Well, if we think about it, and let's say we take a grid at this level and create a vector that points upward, and tell this vector, these points to collide with the furthest point they can find. So this guy is going to snap here, okay? So these points will be snapping here, here, and here, and we'll get something like this. Okay, we'll get something that matches whatever is facing this triangle, and we'll get a geometry like this. Okay, I'm gonna delete those. Imagine we have a box, so we shoot these points and have them collide with the furthest point they can see, and then we take this plane here and connect it with the original plane, its original plane, so we can get a volume out of this. Okay, so this is the first volume. Let's say we do another one from this angle. We create a grid like this and then shoot these points, so they're going to collide with this. See, they're going to skip this detail, they're not gonna collide with this. There's another point furthest than this for this plane, so this point is further away than this point, so this guy will ignore this and follow this line. Okay, so it's gonna come in here, it's going to try. Obviously this part here is not gonna be handled because it's all aligned to this, and this plane won't know how to deal with that. So it's gonna simply put a lot of points here, and then it's gonna try and follow along. So in this case, it's gonna come in here, and then it's going to snap because this is where the furthest point is, and it's going to match this guy. Okay, so it's going to give us basically all the extremes. And if we continue doing this from all directions, we will get from the 6 angles, from positive x, positive y, negative y, positive z, and negative z, we're going to get 6 volumes. Okay, because if we take this geometry and connect it with this guy, it's going to create a volume. If we take all these 6 volumes and intersect them together, we're going to get the information we need. And this is only feasible using VDB volumes. It is feasible with volumes, with Houdini volumes, but this approach only works with volume because we're going to be intersecting 6 volumes together. But we're not going to be doing them all at once. We're going to basically take the geometry and create a bounding box around it, and then for each face of that bounding box we're going to extrude it and then do this projection thing. So let's take a look and see how we're going to set this up. I have the high-res geo here, and we haven't looked at the interior at any point in time, so let's do that. And once we go in, we're very disappointed. There's a lot of issues, there's a lot of floating pieces, and there's not so much that we can do at the volume level to fix this. So let's see how we're going to deal with this and generate the appropriate geometry for us. I'm going to scale this down to match the previous settings I have, and just in case something goes wrong with the VDB volume stuff that we're going to be doing. And then I'm going to assemble this and delete just the biggest part. So I have done that already, assemble node, and then selected the biggest part and deleted everything else. And by doing that, we're going to remove any floating geometry, anything like that. So let's take a look at what we've deleted with this. Okay, and this is the result. Let's see. Yeah, so we got rid of all of that, which helps already. So let's take a look at what we're left with. I think it's, let me make sure that it's set to low res. Okay. So if we go inside, we're definitely in a much better state, but we still have a lot of issues. See these guys, there's just so many things that I want to fix. And I've generated a low res version of this to be able to work with it faster. This one is 4.3 million, and I generated one with 830 basically polygons, which is very close to the original one. And then later I can just swap it once I have the setup. So I'm going to transform this, pardon me, I'm going to transform this a bit, and then I'll explain why I did that once we finish setting this up. It's going to help a little bit to have this oriented in a specific way for the things that we're going to be doing. And then I'm going to create a box, and with this box I'm going to set it to mesh. I'm going to set the type to mesh, and for the resolution we need a lot of details to project. So I'm going to set this to 250 to start with, and then we can increase it later. So this relative reference. And the good thing with mesh is that we get 6 meshes, so we can loop over each face individually without having to do any special treatment or anything like that. Cool. So let's create our first for each loop. And with this one, we want to loop over each primitive. And because it's a mesh, we are easily going to be able to do that. And then I'm going to extrude this a little bit to add another side to it. So I'm going to add a little bit of, just extrude it a tiny bit, and then I'm going to compute the normals. So let's put down a facet node and compute the normal, and this is going to generate the normals that we need. Now all the other faces, if we zoom in closer, the normal of all the other faces are not going to be hitting anything from the object, so I don't have to worry about doing any selection or anything like that. And let's turn that off, and then we're going to add a ray node, and we're going to array that with the original geometry. Now one thing I like to do is I like to expand this a bit to add just a little bit more breathing room for this. So I'm going to put down a transform node and set this to 1.2 and want to scale it based on its centroid. Okay, just to add a little bit of padding. And then we have our extruded geometry. We can actually lower this a bit. And then we're going to ray this. And you can see already it's raying the correct side of this geometry, and it's ignoring everything else, which is great because we don't have to worry about that. And we're gonna leave everything as the default, but check this intersect furthest surface, and this is the key part that we need. We need all these points to intersect with the furthest thing they can see from that surface. Okay, so if we loop over the result now, let me take on single pass. I want to show you the result. So this is one face, the other face, basically all 6 sides. And we're going to convert each one of them into a volume, into an SDF, and then loop over all these volumes and combine them together using a Boolean operation set to intersection. So let me create a VDB from Polygon. Okay, and let's set this to, let's see how much we have. Set this to 0.4. I think we can increase it. Okay, this is too high. Set that. Okay, cool. So let's take a look at the final result. And now the idea is we want to take the first volume, okay, the next one, and combine the intersection of those two together. And then take that result and put it to be used for the next combination. So we combine 2 volumes together. The result of that is going to be combined with the next one, and then the result of that is going to be combined with the next set. This is a recursive loop where we change the data, generate new data, and then the next loop is going to use that data with the new incoming. And this is a very powerful feature of the for each. And now we have our all our SDFs, and we just need to compute the intersection of all of them. And we're going to do it one at a time, and each time send the result back. Now this for this node here, first of all, let's set this to primitive. Let's take off the name, sorry, and this is going to basically give us the proper loop. And then instead of the gather method set to merge each iteration, we need to change this to feedback each iteration. So it returns the result of the process. Whatever happened here is going to be available for us to use in the next iteration. This may be a little bit confusing, but once we do the example, it's going to be clear. Now, to be able to get this result, we need to create the meta import node and set this to, instead of fetch metadata, we need to fetch feedback. And the feedback, we need to stream this. So I'm going to drag this guy in here, and this will return to us the result. And now let's put back the combine, VDB combine. So this is going to be the first volume, and then in the next iteration, it's going to basically put that first volume in here, and then we're gonna stream another volume, combine the result, and then that's gonna go and be fetched here, and then that result was gonna get another volume, and so on and so forth. So that's how the loop is going to work. The result is going to be fetched every time. And we don't have to change anything there, we just need to change this to SDF intersection. And done. That's it. That's how fast it's going. And let's create a VDB convert. And let's convert this into a polygon. And let me copy back the transform here. So I'm gonna create a reference. Copy that back in. And let's delete this and invert transformation. So we restore it back. And this is our surface, and let's dive inside. And done. Look at that. We don't have any more issues with the input geometry. Now we need to increase this a little bit more. So I'm gonna set this. Actually, I'm gonna change the first of all the resolution to 1000. And so we're gonna change that to 1000. I'm gonna change this to 0.08. to go really high res, and let's take a look at that. It's going to obviously be slower, but if you think about all the stuff that's happening, I don't think it's that bad. And we only have to do this once, so we're not gonna be doing it multiple times. And I may have to pause for this to cook all the steps, and then I'll come back in a minute when this is done. Actually, it's going pretty fast, and maybe I can use this time to explain the process again. So we're taking the original geometry. The reason I rotated it a bit is to get better projection based on that on those 6 sides, because our original geometry was aligned perfectly along the height. It's facing upward, and I wanted to rotate that to cause these 6 surfaces to intersect better with the geometry. It may not do a lot of improvement to the final result, but I wanted to change that just to capture more details. Now this workflow is going to obviously miss a little bit of details, unfortunately, and there is not so much that we can do. I think we need to increase this a little bit more, and the details that it's going to miss are things that are really tricky for this to see. For example, we're going to see, when you have a lot of overlaps. Yeah, see, for example, this section here. Yeah, it's going to miss that because the operation is really complex. There's cavities here, and unfortunately, this is the best thing that we can do. But we can capture some of that back. So what we can do is we can put another ray of, and try to ray this result back into the original. So let's see. Let's try a ray node. And because we have subdivisions here, we may be able to capture some details. So let's take on, let's see, not inverse, minimum distance, change the ray to minimum distance. And I think with this, we should be able to capture some details. Now let me, where is it? Let's change the max distance to 0.2. I don't want to change all the other parts. Yeah, so for example, it's capturing some details here. And let's put down a null. And this is the only thing I can think of to restore some of those details back. But again, we're generating a much cleaner geometry. I mean, a perfect geometry now. It's actually fixed a lot of stuff. And the details that we're going to be missing, I don't think they're equivalent to the fix that we made to the geometry. And let me go back and try to explain this one more time. So this is the original geometry. We create a box that overlaps everything, and then loop over each side of this of the box, each primitive, and then extrude that just a tiny bit. Okay, and then compute the normal. And then shoot the rays, tell these points to intersect with the furthest. Now, because these guys are facing this way and these guys are facing upward, it's only going to change the part that makes sense. Okay, so this is what we get. And then we create a volume out of that. And then we repeat this for all the sides. And the result is then going to be combined. So let's take a look. Yeah, so this is the final result. I don't think we'll be able to take a look at the loop here without having to wait too much. But basically it's taking one volume at a time and then running that over. The first time nothing is going to happen because there is no result. And then the next time that first volume is going to be available here, so here, and then it's going to stream another volume, and then it's going to run the combination on that. The result is going to go into this node, it's going to stream in another volume, and then combine that together. And all of that is then combined to converted into a mesh. And without VDB, without the science distance field, we won't be able to do this, and without the ray SOP and that clever feature. And I think hopefully this makes sense to you guys. We are going to need this a lot, especially with the complex stuff that we're doing with the cliff. Let me open the... So this guy had a lot of issues on the interior as well. Not as much as this one, but I think I used it on this one as well. This geometry had some issues, and I fixed it with this method. And it's going to be very important when we start creating the low-res meshes for in-game. It's very important to have a clean mesh with just the outer layer. And this is the method to use. Hopefully you guys learned something new and like this. So now we're going to learn how to create this ground element here, which is basically one single geometry that gets copied and rotated multiple times. It's also being inverted, so it has both sides, and that adds to the complexity of this. And all these guys, the entire ground here is made of a single element, and what we're going to be creating is the main individual asset, and hopefully by instancing it and rotating it, we're going to create a very interesting variety of shapes. So let's see how that's done. I've created a scene already, and it should be empty. If not, we'll make it empty. Okay, so this is my starting point, and I'm going to copy and paste an existing grid that's been Voronoi. Pardon me. And it's basically a simple grid and scattered 12 points, and then this is the result. And I'm going to delete one of these guys. I'm going to use just one part of it. And I'm going to pick this shape and hit a blast, delete everything, and keep this. And the idea is we're going to be doing a little bit more point manipulation in this video. It's a little bit different than everything else we've done. That's why I want to show this example. So let's extrude this to add a little bit of volume. Okay, let's make sure the back we take on output back, and I'm going to add some resolution to this. Now I can divide it obviously, but I want to start with a triangle based mesh, so we have a lot of details to work with. And I'm going to put down a remesh node, which basically takes any input geometry and tries to approximate it or remesh it using triangles. And I'm gonna change the target length to 0.02 to make smaller triangles. Now we have some nice distribution of triangles over this mesh. I'm going to subdivide this one more time to add more resolution to it, and we can always come back to this and subdivide it even more further if we need to. Now what I would like to do is break this shape. Right now it's very uniform, and I like to break it so it's more organic, and I'm going to use a point VOP for that. I'm going to put down a point VOP, add a turbulent noise, and I'm going to set the type to original Perlin noise, and you guys can use anything you like. I prefer this one for this example, and we're going to add that. Let's make sure it's a 3D noise, and let's change the frequency 2.7, and let's reduce the amplitude a bit, something like that. Now you can see the silhouette is broken really nicely, but we're also changing the height, and I don't want that. Now let me put down a facet node to show you the final geometry, because the normals are not changing. So this is the result. You can see there's a lot of interesting details, and I want to keep the original height. I don't want to change the height with the noise. So I'm going to split this into 3 vectors, X, Y, and Z. I'm going to do the same thing with this guy, and then float to vector. And we want to keep the height from the original position, and then only change the X and Z. And then let's connect that, and boom. Now we have a much more interesting silhouette. And the next idea is to take this geometry and copy it a few times, rotate it, and move it up and down to create some interesting layering. So for that, I'm going to create a line just to have some points. I'm gonna make it 0.2 and give it 6 points, so we can make 6 copies. I'm also going to put down a transform node to make sure that my object is at the center. I'm gonna connect that, and we can click this move centroid to origin, which will zero out the object, and this works. It's going to behave better with the instancing because the centroid, the pivot is at the origin. So let's put down a copy to point, and let's deform, and let's copy and take a look at the result. Now each copy is pretty much identical. We don't have any variation or anything like that. And I like to take this curve and modify the points. So I'm going to reuse the same node because it doesn't change the height, and I want to keep that. So I'm going to copy the same node, And let's take a look at the result. Okay, there's not so much changes. So let's increase this. Cool. Let's make it even better. More changes. Cool. So now we have a lot of push and pull just because these points are now moved. And that's where we're copying the geometry. Okay, so the next thing I want to do is, if you look here, the geometry is not being aligned correctly. So we need to create two vectors. We need an up vector and we need the normal. So I'm going to use a create node, call this up vector. It's a vector and it's pointing upward. You can see the object are they changed slightly, but we still need the normal. So for the normal, I can create a another. Let's copy this attribute create. Let's create our normal, and we need, if we give it a positive z-axis, that's the alignment that the copy node looks for. We're going to be getting a perfect alignment, and each object is facing the correct orientation. Now we need to compute the normals because that get messed up. You can see everything is perfectly facing upward. And the next part I want to do is I want to rotate these guys. Now if we take the z-axis here and start changing the values, we're going to see something interesting. Let's see. Not so much. Okay, let's try. Yeah, so if we change it to a different number than 1, we're going to cause rotation to the objects. And what I'm going to do is I'm going to create a randomize node, and instead of this create, I'm going to disable that and create a random n vector. I'm going to change it to uniform discrete, and I'm going to set these two to 0, and here I'm going to set it to minus 360 and 150, and that should give us a little bit of rotation variation between the different pieces. Now the last part that we need is to randomize the scale. I'm going to create a randomize attribute and create a p-scale, uniform discrete. I'm going to set the length to 1, and then the minimum value is going to be 0.6, let's say. The maximum is 1.2, and then the step is 0.1. And let's randomize this to get something a bit different. I want at least the bottom part to be bigger. Yeah, something like that. So this is the effect I'm looking for, and I want to make sure that both sides, the up and down, are interesting because we can copy this and flip it, and we'll get completely different piece. Okay, cool. So the next thing is we're going to move to use volume for this. I'm going to create a VDB from Polygon, and the reason for that is I want to first of all remove all the interior faces because we're just copying a fully enclosed mesh, and then I want to improve the blending between these pieces, and the VDB from Polygon will take care of that. So I'm going to increase the resolution a bit more, 0.003, and the resolution is always relative to the scene scale, so we started off with a very small object. Okay, cool. Can actually go a bit higher. It's not going to add more details, it's going to just capture everything from the mesh. So let's convert this into geometry and take a look at the result. Cool. So now we have a perfect transition between the pieces. See how nicely it blends between all these guys. And the next thing I want to add is I want to add a little bit of erosion like effect here. So I want to add stripes to these sides. And what I'm going to do is I'm going to create another point VOP. And we're going to do the same thing. We're going to create the noise. And let's make it a 3D noise. Pardon me. And I'm gonna split the vector because I don't want to change the height. I want to keep the height as it is. And let's create a float2 vector. So this is the modified x and z. This is the original height, and let's plug that in. Okay, cool. So let's make sure it's a 3D noise. It is. And let's increase the frequency. Okay, cool. So you see we're getting a very interesting stretching effect. And what I would like to do is I'm going to change the frequency on the x and z to something really low. And this will cause the pattern to stretch, but only repeated along a specific axis. So this is the effect I'm looking for. I'm going to lower this a bit. Okay, cool. Yeah, so this is the main thing I'm looking for. We can also add a little bit of noise because I think that would help. So let's do an add and add an overall noise to all the parts. So let's reduce this to something reasonable. And let's reduce this to 0.05, just to add a little, see how that the surface is not flat anymore, and that adds a little bit of realism. Now the next thing I want to add is I want to create some cracks on this. I'm going to show you guys a new pardon me. I'm going to show you guys a new node that's called vein. I'm going to connect it to the color, and this is the result. Now we have a very high res mesh. That's why we're seeing the data, and this creates very interesting patterns. And if we lower the vein attenuation, we get some very interesting details that we can use to push in. And what I like the most about this is the nice soft in transition. Now I don't want to change the x or y or z of the points just by adding this. I don't want to add this. It's a float, so it won't know which direction to push the geometry along, and I want to do an actual displacement. So we're going to use a displace along normal, and this is actually a displacement node. That's how it works. So I'm going to connect the amount, the p, and then let's connect the position again. And now it's too high, so let's lower the scale, 0.01. Okay, cool. So see, we're getting some very interesting effects. Now this stuff is getting disturbed a lot, and that's because of the amount of details we had, the amount of geometry, and we don't want normals here. We don't want to change anything here, so we're going to create a mask for that. And we can play with the settings here. We can add more noise. This option has a lot of cool stuff. So let's actually make another one, and let's add both of them together. Okay, you can see we're getting a lot of interesting cracks, and let's let me show you what the node does. So if we increase that vein attenuation again, you can see how it's creeping in and creating some more interesting details. Yeah, we should also look at using this in the with volumes, I think. You can lower the frequency at which the line breaks, and that will create smoother lines. And you can also change the type from the projection from linear to cylindrical and spherical, and each one of them gives you a different type. So I'm going to leave this as it is, and I'm going to lower, keep the attenuation at that value, and we're going to add it back to the small details. So I want to add basically a layering of both of them. Okay, cool. Something like that. And then we're going to create a mask to remove all of this. So how can we isolate that? Well, we can take the normals and do a dot product, and that should create the mask for us that we need. Okay, cool. So you can see everything that is facing upward is now colored with white, and everything that is not is colored with with black. We can also ramp this to isolate the range a bit better, and then let's add a multiplier to all of this. So multiply, and we want to multiply the result with the ramp. Okay, and let's take a look at geometry. And now we're not changing it that much, but it is still being changed. So let's improve the ramp a bit and see what we get. Okay, cool. So it's working much better now. And we just need that part. We just need the top part. Now it looks like there is a lot of noise. So let's make sure we yeah, the normal we're capturing all the surface details because we added a little bit of noise to all of it. But if it was flat, maybe let's add this before we added the surface normal. So that we can soften it there, and then let's take a look at this now. Cool. So yeah, and that's basically how I made the rocks. And now let's see how much geometry. Okay, cool. So let's create a copy node. Copy 2 points. I'm going to copy the up vector, the random n, and the randomized p-scale. Hopefully this doesn't crash. So I'm gonna pack an instance. I'm gonna copy these guys, and let's create a grid. Let's create a grid. Make it 100 units by 100. That's too much. Let's try 20 by 20. Okay. And let's scatter some points. Let's try 10 first and see what we get. Okay, cool. Let's increase. Cool. So basically that's how I made the ground. And we're going to, when we get to, I think week 8 or 7, we're going to learn how to instance this properly and improve the copying of all these things together. And I think that's pretty much it. In the next video, we're going to learn how to create booleans to do volume subtraction. So we're going to be able to create something like this. And this is the wall asset, and we're going to use volume to subtract some data. So in this video, we're going to learn how to create booleans between different VDB volumes. And I have this logo here, which is a PNG, and it has an alpha channel. And I'm going to use the image to create geometry. So I'm going to put down a trace node, and this can sample a text file, sorry, a image file. So I'm going to paste the path to the object, to the image, and let's lower the threshold so that I can see the points. Cool. So now we have actual geometry, and let's, how much points do we have? Yeah, it doesn't matter. So I'm going to extrude this. Let's make it a bit bigger too, and let's extrude it. Give it some thickness. 0.1. Okay, and let's output back. Cool. And let's create a bound node, and just to have something to encompass this, so something like that. And then I'm going to make it bigger, and this volume is inside of that. Cool. So let's say this is our this is our wall, for example, and we want to subtract the volume of this guy. So I'm going to create a VDB from Polygon, and let's say this is the main wall that we created. Let's increase the resolution, so 0.001, and then I'm going to do the same thing for this. Okay, so this is our volume, and in order for us to subtract it and see it, we need to make another geometry that is bigger. So I'm gonna copy this and put down a transform node and scale it 3 times, 4 times, and let's template this. I want to see it exit the volume, so 5 times. Okay, and let's copy this and also make a volume out of that. Now I'm going to do this, the subtraction, the Boolean function between these two. So VDB combine, and this and this, and I want to compute the SDF difference, and boom, we have volume subtraction. Now once we remove the volume, I'm going to add back this, and it's inside, it's thinner, and we can actually scale it down or push in the points to create a little bit of gap. And you know what, let me show you something new. So this guy, once we are in the SDF land in the science distance field, we can do a little bit of volume processing. So there is a VDB SDF reshape node, and it has a dilate and an erode function, and the dilate will basically push the voxels outward or along the gradient of this, and the erode will do the inverse. So we want to expand this a little bit to add more room, and that does it already. Let's increase it to show you the effect. You can see it there, and we can do the inverse as well with the erode. We can shrink the volume or push it in. So let's try dilate, and let's add 2 voxels, and let's see the result. Now we should have more room, and I'm going to VDB combine the result with this. So this guy with this guy, and the result is SDF union, and now we should see our new volume is inside. Okay, this is the original and it's inside, and the reason I added back in is to create some interesting edges here. And let me do something. Let me copy this, paste it here, and paste it here. Oh, sorry, I deleted the node accidentally. Yeah. Okay. Okay, cool. So they're all linked, and what's the resolution we have now? Let's increase that to 0.06 to add more details. Cool. And let's VDB convert this into polygons. Cool. And you can see now we have that gap in there. That's because of the erode effect that we did. Let's turn it off. You can see it's all blending in nicely. And let's convert the result with just the Boolean to show the difference. Okay, so that's without the volume added back in, and this is with the volume. And this definitely helps to create a little bit of gap in between both of them. Cool. And that's pretty much it. That's how I created this result. Now, one thing I've done is, let's try this. So we need to create a mask that only isolates this, and I believe the way I've done it is once we are in the point land, we can do I think I did color transfer. Yes, so this is the example I've done. I converted this into a volume by itself, and then this is the result, and I created a color here that is black just to create a mask. Okay, so this is the result of everything together, and then I made this, let's say, red, and just did a transfer attribute, a cheap attribute transfer. It's gonna take, okay, so let's reduce this to 0.1, and there you go. it's creeping in a little bit. So let's reduce this to 0.01, and there is the mask. Cool. I think that's pretty much it for this week. The last thing I wanted to talk about is that wall, the big wall. This guy. There's another version of it being bent. So here, this is the version of it being bent. And what I've done is I simply use the bend node in Houdini. And I'm sure you guys know how to use this. So that's a box. I'm gonna add some geo and use a bend node. And let's make sure it's at the origin. Move to the origin. Cool. And I like to push the object all the way so that the beginning starts at 0, and this makes it easier to select the to set the bend node. So the capture direction, I wanted it to capture along this axis, so it's the X axis, and then the distance, the length is the object length, which is 3.3. Sorry, 3.3. And now we're pretty much capturing everything. The up vector should be correct. No, it's not. Let's try the z-axis. I always try this myself. And now we can bend the geometry in the direction that we want. And then we just have to copy the wall a few times to create the circle. I definitely had a circle that I was trying to fit the size, so you guys can do something similar as well. So in this week we've created a variety of assets. We've made this one, we've made this, which is the sharp cliff that is also flipped and used in different ways. We've learned how to create the ground, the walls, these guys, and then the stairs, which I showed. And then these are also very similar to this. I just deleted certain parts and I added the stripes, which we learned how to do as well in here. It can be done in volume VOPs or as a geometry process. And when whatever assets you're going to be creating, try to make a variety of them that have that each has a different scale. So you can make mid, small, and large details, and make sure you have the base to have as much detail as you need, because for example, when we look at this, we don't really notice, it's not easy for us to distinguish the pattern, but it's one asset, and even though it's actually straight copy one-to-one, we still don't have a very good indication as to when the tiling is starting to happen. And this is great because we don't have to worry too much if our asset has a lot of details. We're not going to easily notice the complexity, the repetition. And I would like you guys to create as much asset as you want using the various techniques that I showed, and try to keep in mind in the end that we're going to be creating an environment or something similar to that. So make sure that whatever you're going to create is something that can be combined together to create an environment. And use any technique that we showed, that I showed here. I would love to see the color attribute being used, being generated, because that's going to come in handy a lot. And then whenever you create the asset and ready to export, make sure to add a rest attribute at the end of the export. So when you're done, just make sure you add a rest attribute, and then make sure to use the pipeline tools to export the assets and everything. So make sure that you have the geometry needed for us to be able to import this, because starting from next week we're not going to be creating assets anymore. We're going to be reusing everything we've made, shaded, lighted, and hopefully creating the environment with it. And I think that's pretty much it. Thank you guys, and good luck with this, and see you next week. Bye bye.